welcome back. Today is day 26 of this 30 days Leetcode challenge, and our today's question is longest common subsequence. This is a pretty standard question when it comes to dynamic programming, and let's discuss this. So we are given two strings, text1 and text2, and we have to return the length of their longest common subsequence. So when they say subsequence is not the same as substring. So when I talk about subsequence for let's say A B C D E this string, then A C E is one of the subsequence. A C D is also one of the subsequence, but A E C is not a subsequence. So we have to find the length of the longest common subsequence in two strings. So there can be multiple possible subsequences in string in text1, and there can be multiple subsequences in text2, and we have to find the common subsequence, the subsequence which is available in both the strings, and of those subsequences, which whichever one has the longest length, that needs to be returned. So here so in this case, what we'll do is we'll solve this using a recursive approach, and then use memoization to avoid repeating the solutions. So for recursive solution, what I'll do is I'll pass in the index in each of the string. So basically we'll have two pointers, one pointing to each of the strings, and we'll check if the pointer where the characters are where if the characters where the pointers are pointing to, if they are equal, then we have at least one subsequence, and whatever is the length of the remaining substring, that can be added. So and if we find that the characters are not equal, then in that case we have two possibilities. Either we take the first string completely and discard the first character of this next string, or we discard the first character of the first string and use the complete string that is left. So that is what I'm planning to implement here. So I'll have a LCS function which will take text1 and text2 as the input, and I'll say we'll start off from the 0th index, and this is expected. This LCS function will return and the longest common subsequence length, and it is taking both the string input and I and j as the pointers pointing to each of the strings. And if we find that the character at I, if that is equal to the character at j in the second string, then we can say that I have found at least one a subsequence with at least length of 1, and whatever is the remaining string, that can be the length of the remaining the longest subsequence in the remaining substring, that can be added to 1. Else, if we find that the characters are not equal, then we have two possibilities. So I'll say the first one will be longest subsequence, but in this case what I'll do is I'll use I plus 1 and j. So we won't be incrementing the second pointer, we'll just increment the first pointer, and the second possible solution can be where we are incrementing the second pointer and not the first. So out of these two, whichever is the max value, that that will be our solution. Now the base case here would be that if our I pointer ends up reaching the length of the string, or our j pointer ends up reaching the length of the string, then in that case we have to return 0. Now this solution will work fine, but obviously we are repeating some sub problems, solution to some of the sub problems. So consider, for instance, 3 comma 2, and later on, if we end up using I and j plus 1, so in that case there will be one possible we'll end up repeating the solution for when we go for 2 comma 1 and 3 comma 3, those kind of scenarios. So we are obviously repeating some of the sub problems. So what I'll do is I'll use a map 2D array for storing for caching some of the values that I'll be calculating, and it will depend on the first the dimensions will be m cross n. So m being the dimension, the length of the first string, and n being the length of the second string, and that is what I'll pass in to this function as well. So this is the map, and now after checking the range, if I find that the map already contains value for I comma j which is not equal to 0, then I can just return whatever value I have cached, and the cache will be populated here. So the value for I comma j when the characters are equal will be this, and the value for I comma j when the characters are not equal will be this, and that is what will be uh, returned from this function. So now we are caching the values and avoiding recalculation of the same values again and again. So let's run this. Now we are getting a compiler error. Okay, we have to pass the map function as well here for wherever we are doing recursive calls. So let's run this. Yeah, so our answer matches the expected answer. So let's submit this, and our solution has been accepted. So there is a better explanation as well, which uses the bottom-up approach. So I have added a link in the description, which is in the video that you can take a look. That video is not by me, but I found that to be pretty detailed, and explains the concepts that are used in longest common subsequence. All the three approaches with using recursion, memoization, and bottom-up approach for solving this dynamic programming problem has been discussed in that video as well. So do take a look, and if you like this video, give it a thumbs up, and do subscribe to my channel if you want to be notified about when I upload the next day's problem. So thank you.